Do you see the screen?
Yes, doctor.
Do you see the screen?
Yes, doctor. مبين.
Do you hear me?
Yes, doctor. مسموع.
Guys, do you hear me?
دكتور انت تسمعينا؟ انت نحن عم نسمعك.
Yes, doctor.
Okay, so let us start. Okay, so we were doing problem 6. A boy at O throws a ball in the air with a speed v0 at an angle theta 1. If he then throws another ball at the same speed v0 at an angle theta 2 smaller than theta 1, determine the time between the throws so the balls will collide in mid-air at B. So in this problem here, we have the case of a projectile motion. We have two particles that are thrown at different times, okay? And we want to determine what will be the time between the throws if the balls collide at point B. So here they gave us the equation of the coordinates of point of meeting. So the meeting point is known. They will give us the values of x and y, and we have to find what is the relation between delta t of throwing the two balls and x and y. Okay, so here x, y are given, theta 1, theta 2 are also given. We have two unknowns here. We have the first unknown is t. T corresponds to the meeting time. We don't know it. Okay, so the first unknown here is the meeting time. And the second unknown is delta t, which is the time elapsed between throwing A and B. So second unknown is delta t, which is the time between the throws. Okay, so the time between the throws, this is what we want to calculate, is delta t. Since we have two unknowns here, we should try to write two equations. And the two equations are very simple here, because when the two balls will meet together, okay, they will have common x and common y. So the two equations will be that x1, x of the first particle, should be equal to x of the second particle. This is equation number 1. And equation number 2 will be that y of particle 1 should be equal to y of particle 2. Okay? So here, what we will do is, after putting the conditions that x1 is equal to x2, y1 equal to y2, we will obtain two equations which will allow us to solve for the two unknowns, t and delta t. So let us write the equations. So first, along x, okay, the equation of the first particle is x equals to v0 cosine theta 1 times t. okay, because here it's a projectile motion, and we have in x direction no acceleration, velocity is constant. So you have for each particle, you know the speed v0. You should decompose the velocity into two components, one along x, one along y. So the component of v0 along x is v0 cosine theta 1 for the first particle, and v0 cosine theta 2 for the second particle. Now, what is the other difference between the two particles is that the time of throwing is different between the two. First, we throw the first particle at an angle theta 1, then we throw particle 2 at angle theta 2. So the first difference is the angle. So here it's v0 cosine theta 1. Here it's v0 cosine theta 2. The second difference is that here we have the chronometer of the first particle will, the 0, time equal 0 will correspond to start of motion of particle 1. So time t will represent the total time of motion of particle 1, while particle 2 is thrown after a certain time step delta t. This is why we should count time for particle B. The time of motion will be t minus delta t. So now, writing x1 equal to x2, we get the equation number 1, that v0 cosine theta 1t should be equal to v0 cosine theta 2 times t minus delta t. So I repeat, this is the first term of the equation here represent x1. So this is x1, okay? And the second part is x of point of particle 2. This is equation number 1. We need a second equation because, as we said, we have two unknowns, which are t and delta t. Now, the second unknown will be by writing that y1 is equal to y2, okay? And we know that in projectile motion, the equation of y is the following: minus half 80, plus half 80 squared, but here a is minus g, so it's minus g over 2t squared, plus v0yt, and for particle 1, v0y is v0 sine theta 1. And since the beginning of motion corresponds to t equals 0, then the variable is t. And we should add plus y0, but since we considered the origin of O for the frame, then y0 is equal to 0. This should be equal to y2. For y2, it's the same equation form, but the difference is that first, the time is counted for motion of the second particle is t minus delta t. So I will replace t in this equation by t minus delta t. And the second difference is the angle. So y component for motion of particle 2 is v0 sine theta 2. Okay? And in this way, I can calculate, I have two equations, two unknowns. So I can calculate the time t function of my variables x, y, v0, so function of my variables which are v0 and theta 1, theta 2. Okay, so by eliminating t between the two equations, I can get delta t function of v0, theta 1, and theta 2. Okay, and what I want to tell you here is that this relation, you can get it from trigonometrical calculation. But for me, what is important is to reach this step. Once you reach this state, it's like a mathematical solution to get the result. So the most important thing in the problem is to put the two conditions and then say I have two equations with two unknowns. I can find delta t function of v0, theta 1, and theta 2. So as you can see here, delta t is independent of the value of x and y. It's depending only on the angles theta 1, theta 2, and v0. Okay? Any question on this? I don't know if there is a problem because I cannot hear you. So if you want anything, please put your question in the chat. Okay? So I don't know what is the problem because here I have, my computer is not muted, so I don't know why I cannot hear you. Okay. So please, if you need anything, type it in the chats, okay?
Yeah.
Now let us continue. Problem 7. A particle P moves along the curve y equals to bx squared plus c with a constant speed v. Determine the point on the curve where the maximum magnitude of acceleration occurs and compute its value. So you have here the particle is moving along a path of given equation. The equation is y equals to bx squared plus c. Now we want to determine for which point on the curve we will have the maximum magnitude of acceleration. So you know that whenever we are moving on a curve, the acceleration will be decomposed into two components: normal acceleration and tangential acceleration. Okay? Now, in order to determine these values, if we read well the given, they said that it's moving with a constant velocity, with a constant speed v. Because the speed is constant, okay, from this sentence we can deduce that the tangential acceleration is 0. Because by definition, what is a tangential? A tangential is dv by dt, okay, is equal to dv by dt. So since we have constant velocity, then the tangential acceleration is 0, and we only have the acceleration in this problem will be only restricted to the normal component of acceleration. Okay, so now to find the normal component of acceleration, we know that an is calculated by v squared over the radius of curvature. So an is v squared over rho. Okay, now v is given, the value of v is given, so we just need to determine what is the radius of curvature. To determine the radius of curvature, we will use the function we have seen together in the course material, that the radius of curvature is given by radical of 1 plus y prime x square كلها سوا to the power. يعني هي الراديكال فيكم تحطوا بدل الراديكال to the power 3 over 2. اوكي، او بتحطوا radical 1 plus y prime x squared to the power 3 over the absolute value of the second derivative. هلا هون ما حطوا absolute value because it is already positive, the second derivative. Okay, but in general we should put over the absolute value of the second derivative. Now, in order to calculate rho, all we have to do is to calculate the value of y prime and the value of y second x. Okay. Now, if you look at your function, you have the function y of x is bx squared plus c. So the first derivative will be 2bx. Okay, and the second derivative, so y prime is equal to 2bx. While the second derivative will be a constant, a positive constant, equal to 2b. So if you derive another time, you get 2b. Okay, so you can deduce here that the minimum, what I want to determine here is the position for which the acceleration is maximum. To have a maximum, the radius of curvature should be minimum, because an is v squared over rho. Okay, so now our purpose is to determine what is the value of rho minimum. If you look at the expression of rho, here you have a constant, and here in this term I have 1 plus a certain number square. So y prime square is always higher or equal to 0. Okay, so the minimum value of y prime square will be what? Will be 0. Okay, so in order to have minimum rho, y prime should be 0, because for any other value of y prime, rho will be higher, okay, because rho will increase with y prime, okay. So the rho minimum will correspond to y prime square minimum, which correspond to a value of y prime equal to 0. So I can deduce here that rho is minimum for a minimum y prime, and for y prime إذا بدكم equal to 0 لأنه إذا كانت negative y prime وقت أعمل square هيطلع لي number that is higher. So the minimum value of y prime square will correspond to y prime x equal to 0. And we know that y prime x is 2bx. So we can say that y prime is equal to 0 for x equals to 0. So this is the position for which normal acceleration will be maximum. Normal acceleration will be maximum for x equal to 0. So now, knowing the position x, we can get the value of y prime, which is 0, and y second is 2b. Then we can calculate the value of the corresponding value of rho by replacing in the equation. Okay? And once we got rho, we can calculate the acceleration, which is v square over rho. This will give us the maximum acceleration since v is constant and rho is the minimum possible value for the radius. Okay. Any question on this? So please, yes, I will check your chats. Okay. You are telling me that in the settings there is something wrong, and because in general you are not muted in the settings. Okay, I will try to fix this. Just 1 minute. Okay. Anyway, I will continue now, okay, because I don't want to interrupt the session. And I will check this after we finish this session. So if you need anything for today, please type it in the chat. Okay. Problem 8. The boy slides down the slide at a constant speed v. If the slide is in the form of an ellipse, defined by the equation r equal constant and z equal to minus h theta over 2 pi, determine the boy's angular velocity about the axis and theta prime, which is and the magnitude of his acceleration. So here in this problem, we know that r is constant, and we know that z is given by minus h theta over 2 pi, and we want to determine what is the boy's angular velocity. So we want to determine theta dot, and we want to determine also the magnitude of his acceleration. So we want to determine a. Okay, this is the question. So here we are working in cylindrical coordinates, okay, because we are giving us the equation function of theta, and we know that r is constant. So all we have to do here is to remember what are the equations in cylindrical coordinates. So we have seen together in the course material that in cylindrical coordinates in 3 dimensions, the velocity v can be decomposed into radial component, transverse component, and component along z. So v is equal to vr times ur, okay, plus v theta times u theta plus Vz times Uz, okay? And what is Vr? The expression of Vr is the derivative of R with respect to time, okay? So we know that here R is constant. So what is dr by dt? Dr by dt will be 0, okay? So here we have that Vr is defined as dr over dt. And since R is a constant, then dr by dt will be 0. So here in this problem, no component of velocity along the radial direction, since R is constant. Now, concerning v theta is calculated by R theta dot. Okay. And we don't know theta dot. We want to determine what is the value of theta dot. This is why they gave us additional information in the problem. They gave us the speed of the boy. Okay, so the speed is constant. It's a constant speed, and it's given to be equal to 2. Knowing the value of the magnitude of the speed, this will allow us to calculate theta dot, because v theta is function of theta dot. And Vz is what? Vz is the derivative of z with respect to time. It's equal to dz by dt. Okay? And we know that z is given function of theta. So we can find the value of z dot. Okay? Z dot is equal to minus h theta dot over 2 pi. Okay? So it is minus h theta dot over 2 pi. Okay? Now, once we have the components v theta and vz, we can say that the magnitude of the velocity, so the magnitude v, which is equal to 2, is equal to what? It's equal to radical of, so it's radical of v theta square plus vz square. So just we have to replace v theta and vz by values. Okay, v theta is r square theta dot. When we do it square, it's r square theta dot square, and vz square is h square theta dot square over 4 pi square. So you can see here that you have in common with the 2 theta dot square. So you can take it outside of the radical, and then you will end up with one equation with one unknown, because it will give you theta dot. I will take theta dot outside, and inside the radical, I will have r square, which is known. R is given to be 1.5 meter. Okay, I know it. So it's radical r square plus h square over 2 pi over 4 pi square. Okay, so this equation will give me the value of theta dot. Okay, so from here I can get the value of theta dot. Now I will move to the acceleration. I want to determine the magnitude of acceleration. To find the magnitude of acceleration, I should go to the formula of acceleration. So let us see together, because the pen is slow. Maybe you have lagging also. So let me show you here the result. So for velocity, as we said, we did a radical of z prime square plus r theta dot square. Okay, and both have in common theta dot. This is why we have taken theta dot outside the radical. So in this case, we can get theta dot function of the parameters given, which are the velocity, the value of r and h, all are given. So I get theta dot. Okay. Now for the acceleration, you know that in cylindrical components, your acceleration can be divided also into AR, A theta, and AZ. But because R is constant, no value of AR. And AR is given by R dot dot. Okay, and since r is constant, so r dot dot is 0. So because r dot dot is 0, no value for AR. Now, concerning acceleration along Z, okay, acceleration along Z is Z dot dot, okay? But let us check together what was Z dot. Z dot was h over 2 pi times theta dot. And they said here that V is constant. Because the speed is constant and theta dot is function of the speed, then theta dot will also be constant. So here, as you can see, theta dot is equal to is function of parameters, and all these parameters are constant. V is not changing, R is constant, and H is the same. Okay, so from here I can deduce that theta dot is a constant, and because theta dot is constant, then z dot also, which is function only of theta dot as variable, will be constant. So also z dot is constant. This is why z dot dot will be 0, because I am deriving a constant value. So z dot dot also is 0. So I can say that my acceleration here will be reduced only to the component along theta. So I only have that a is equal to a theta. And we know that a theta is calculated from the following formula. A theta is equal to r theta dot dot, r theta dot dot, minus r theta dot square, minus r theta dot square. Okay? And since theta dot is a constant, then theta dot dot is 0. So this term will cancel out. Then I deduce that a theta is minus r theta dot square. And in this case, I have that, for the formula here, مش, it is, this is the value of, let me fix it one second. Okay, the formula for AR هي R dot dot minus R theta dot square. خلينا نظبط لكم اياها هون. Okay, so for AR I don't have R dot dot, but I have the second term اللي هو minus R theta dot square. Okay, while a theta, so let me fix it here. While a theta is given by R theta dot dot, okay, plus, so plus 2R dot theta dot, plus 2R dot. انتوا على طول بالاكزام عملوا formula sheet, okay, to not forget the formula. So plus 2R dot theta dot, okay. So here for a theta it will be 0 because theta dot dot is 0 and R dot is 0, okay. So no value for a theta, while AR will have only the component minus r theta dot square. So in total, if you want, the acceleration A will be restricted to AR, okay, and it is minus r theta dot square. So in magnitude, the acceleration will be equal to r theta dot square. I already calculated the value of theta dot, and I have the value of r, so I can deduce what is the value of acceleration. Okay, so here I just should do the analysis and write first A in terms of AR, A theta, AZ. Then since A theta and AZ are both 0, so the acceleration will be reduced to AR. And also AR, I can simplify in its calculation because R dot dot is 0. So I will only have that AR is minus R theta dot square. Okay? Any question on this? Okay. So let me start another problem. the motion of point P is constrained by the curved slot in OB and by the slotted arm OA. If OA rotates counterclockwise with an angular velocity of theta dot equals to 3t to the power 3/2, where t is in seconds, determine the magnitudes of the velocity and acceleration of P when theta equals to 30 degrees, knowing that when t equal to 0, theta is equal to 0 degrees. So here, what we have a curved motion. So we have motion along a curve, and the equation of the curve is given by r as a function of theta. So you have that r squared is given by 4 cosine 2 theta. Okay. Now, concerning theta dot is given as function of time. And what we want to do here, we want to calculate the magnitude of the velocity and acceleration of point P. Okay. So here also, we will apply the equations of V and A. So to start with V, as we said, V is decomposed into VR and V theta. So to calculate the magnitude of V, I should find what is the value of VR and what is the value of V theta. So V is the radical of VR squared plus V theta squared. Now I will find separately VR and V theta to be able to calculate the value of magnitude of V. So to start with the definition of VR, VR is equal to R dot, and R dot represents the derivative of R with respect to time. And as you can see here, they gave us R function of theta. So we will derive this relation, we will derive it with respect to time, okay, using the chain rule. So first, the derivative of R squared will give you 2R R dot, okay? Because from chain rule, I first derive with respect to R, and then I multiply by dr over dt, which is R dot. In this way, I will obtain the derivative with respect to time of the first term. Second, the second term of the equality is equal to 4 cosine 2 theta. If you want to derive 4 cosine 2 theta with respect to time, then first you derive it with respect to theta, okay? So first you say that I want to derive cosine 2 theta with respect to theta, which will give you minus 2 sine 2 theta, and you multiply by 4. So it's minus 8 sine 2 theta times d theta by dt, so times theta dot, okay? So this is the derivative with respect to theta, then you multiply it by theta dot using the chain rule. Now, once you get this equation, then you can relate, you can find the expression of R dot. So this is R dot, function of theta, theta dot, and R. Now, in this problem, in the given, they gave me that at the point of interest, I want to determine the velocity and magnitude for theta equal to 30 degrees, okay? So for theta equal to 30 degrees, I will replace in my equation here, okay? Knowing that theta equal to 30, I want to get what is the corresponding value of theta dot, okay? How to do this? You know that I don't have an equation for theta. I have an equation for theta dot, but I can integrate theta dot to get theta, because I know that theta dot represents the derivative of theta with respect to time, okay? So now from this relation, I can say that theta can be obtained by integrating theta dot, okay? So since theta dot is d theta by dt, I can say, I can separate variables, okay? So I can write that d theta is equal to theta dot times dt, and theta dot is 3t to the power 3/2. So I replace 3t to the power 3 over 2 times dt. Okay. Now, if I integrate this relation, I will integrate it for time between 0 and t, while for theta, also I will integrate it from 0 because they gave me a boundary condition. They said when t equal to 0, theta is 0. So this is the boundary condition I should use in my integration. So here I will integrate between 0 and theta. And here I will integrate between 0 and t. And this integration will give me theta function of time. It will give me that theta is equal to, when you integrate t to the power n, it's t to the power n plus 1 over n plus 1. Okay? So you will get theta equals to, and here is 1.5. Okay? So if you integrate, it is 3 times t to the power 2.5 or 5 over 2. Okay? 5 over 2 divided by 5 over 2. Okay? In this way, I can get theta function of time. And once I get the expression of theta, so over here 2.5. Okay? Once you get theta as a function of time, then you can say, what I am interested in this problem is velocity and acceleration for theta equal to 30. So all I have to do is to replace in this equation theta by its value. But please pay attention. Theta, you replace it in radians, not in degrees. Okay? Because here, look, they gave you unit theta dot is in radian per second, not in degrees per second. So the value of theta in the equation is in radian. So all you have to do is to do the conversion from degrees to radian, because you know that pi radian corresponds to 180 degrees. Okay, so to find what is the angle corresponding to 30, all you have to do is to multiply pi by 30 and divide it by 180. So here it's pi over 6. Okay, so by replacing the angle theta by pi over 6, then you can get the corresponding time. And once you get the corresponding time, you replace in theta dot expression t by its value, you get the value of theta dot. And once you get also theta is pi over 6, you replace it in the equation of r here, you get the value of r. Okay? So now, going back to my expression, in my expression here, I can get, I got already, theta is pi over 6. I got theta dot, what is the value of theta dot, because I calculated the corresponding time. Then I can replace in my equation and find the value of r dot. Okay? Now, once I got r dot, I calculate the radial velocity. Now, concerning the transverse component of velocity, we know that v theta is calculated by r theta dot. I already calculated r and theta dot because I need them to calculate r dot. So now all I have to do is to replace back in the radical equation to get the magnitude of my velocity. Okay? Now, in a second step, I need to determine the acceleration. Okay? So to determine the acceleration, I should also use formulas for cylindrical coordinates. Okay? We know that, as we have seen in the previous problem, we have that the radial acceleration is calculated by r dot dot minus r theta dot square. So here, I need to determine what is the value of r dot dot, because already I know r and theta dot from the previous calculation. Okay? And concerning a theta, it is given by r theta dot dot plus 2r dot theta dot. Okay? So now, what is missing for me is r dot dot to calculate, and the value of theta dot dot, because I need theta dot dot in the expression of a theta. So it's r theta dot dot plus 2 r dot theta dot. Okay. Okay. So now, in order to calculate the values of r dot dot and theta dot dot, first, to get r dot dot, I have two methods. Okay. Or once I get the expression of r dot, function of theta, theta dot, and r, I derive this relation with respect to time. Okay. But what is easier is to derive the previous relation. As I told you last time. Okay. Always try to derive the less complex equation, because in this way you will avoid having something over or radical. Okay, so here it's easier to derive this relation with respect to time. If you derive this relation with respect to time, okay, you have first here the product of two functions. You have u times v. Okay, so when deriving u times v with respect to time, you have u prime v plus v prime u. Okay, so first it's 2 times r dot times r dot. Okay, which will give you r dot square plus 2 r dot dot times r dot. Okay, so here if you want to clarify it for you, this is r dot. Sorry, this is 2r, and the first time you do 2r times r dot dot. Okay, this is the first term because you are deriving first r dot, and the second term will be 2r dot times r dot, and it will give you r dot square. Okay, so you end up with 2 times r dot dot plus r dot square. This is the derivation of the first term. Okay, now the second step is to derive this term with respect to time. Here you have also the product of two functions اللي هن sine 2 theta. minus 8 is constant, you can take it outside, so you take minus 8 outside and you derive. You have u times v. U is sine 2 theta and v is theta dot dot. Okay, so the first term is u v prime. V prime is theta dot dot. And the second term is u prime v. The derivative of sine 2 theta with respect to time is cosine 2 theta times theta dot. And you have again times theta dot. And you will end up with cosine 2 theta times theta dot square. Okay? So in this case, the only unknown in this equation will be r dot dot. You will be able to express r dot dot function of all the other variables, theta, theta dot dot, and r dot. Now, how to get theta dot dot? To get theta dot dot, you should derive theta dot with respect to time. We have here the expression of theta dot with respect to time. It is given. Okay. So here, if we go back to the given, we have the expression of theta dot function of time. Theta dot is 3t to the power 3 over 2. From this relation, we can get the theta dot dot by deriving this relation directly with respect to time. Okay, so if I derive this, I will get that theta dot dot, okay, is, you know that the derivative of t to the power n is n t to the power n minus 1. Okay, so here n is equal to 1.5. So the derivative will be 3 times n, which is 3 over 2. So 3 times 1.5 times t to the power n minus 1, which is t to the power 0.5. Okay, in this way, you have the expression of theta dot dot. Okay, so now since I calculated the value of r dot dot and theta dot dot, then I can replace these values in the expression of AR and A theta, okay? And then once I get AR A theta, I can do radical of AR square plus A theta square. So let us see together the details of the solution. We can see them here. So first, after calculating r dot dot, okay, we can replace and finding the expression of theta and theta dot dot. Then we can replace into the equations and we get the value of all the variables needed, theta dot dot, r dot, and r dot dot. Now, once all these variables are determined, all I have to do is to replace into the expression of the velocity and the expression of the acceleration. Okay, so here v is calculated by radical vr square plus v theta square, and a is calculated as a radical ar square plus a theta square, where ar and a theta are given by the following formula. So now by doing the replacement, I can get the magnitude of the acceleration. Okay? Any question on this? Okay. So let us move to another problem. The following crane is used to hoist the load. If the motors at A and B are drawing in the cable at a speed of 2 feet per second and 4 feet per second respectively, determine the speed of the load. So here I want to determine what is the speed of my load here. Okay, function of the velocity at A and the velocity at B. So this is a problem of pulleys with a system of cords. What we have here, first, we have two motors. These two motors are drawing cable inward. Okay, so what is happening is that I am taking a length of the cable and rolling it over the motor. So whenever you have a motor, you should take a coordinate for the motor. Okay, then here, this coordinate, which I will call S of A, will not represent the length from this point to this one. No, it will represent the length that is rolling over the motor. So it's a variable length depending on the amount of rolling inside the motor. So SA will represent the length that is enrolled in motor A. SB will represent the coordinate of length enrolled in motor B. And since I am trying to lift the load, then I need an additional coordinate for the load. I will call it S of C. And what I will try to do here, I will try to relate S of A, S of B, and S of C in order to determine the speed of the load. Okay? So as usual, in such a problem, the strategy is to write the total length of the cord and then derive the relation. So first, my cord is starting, if I start from here, let's see, okay? Let us follow the cord. When moving from this point to this one, this length here is equal to SC minus a constant, because look, from here to here, I have a certain constant. So as usual, I will lump all constant in one term, okay? So here I will consider that I have from here to here, it's SC. Rolling over the pulley also, it's a constant, so I will include it with constants. I have from this point to the point that is up, I have from here to here, it is SC also minus constant. So as we said, all constants will be lumped in one value, okay? And here, this distance from here to here, it's a constant. Yani I can also not put it or include it just with all constants in the problem. So here, you can call it H if you want. H is constant, so when you will account for it, when you derive, it will not be included. And then when I go from this point to this point, this will represent the chord length which is enrolled in the motor, so it will be given by SA. Now, I didn't finish. From here to here, I have a constant, I will call it L, for example. So also it will go in the derivation. Now, this length here is SC minus a constant. So this is also SC minus constant. Okay. And here I am turning over the pulley. So it's a constant. And the final length here is also the same value here, SC minus constant, plus H here, from here to here. And the final value is plus SB, okay? So if I want to write in detail, in total, what is the total length of my chord? I have SA one time, SB one time, and for SC, it is included 4 times. One here, it's SC minus constant here. Here it is also SC minus constant, so it's another time, 1, 2. For this length, it is the 3rd time where I have SC. And for this part also, I have SC minus a constant. So SC is figuring out 4 times in my equation, okay? So now, if I want to summarize, what is the total length of the chord? It is SA plus SB plus 4 times SC, because SC figured out 4 times in my problem. So plus 4 times S of C equals to, I will lump all constant at the other side. Yani I will add all constant together, plus or minus, it doesn't matter. They will give me 1 constant at the end, okay? So my equation here will be SA plus SB plus 4SC equal to constant. So if I derive this relation with respect to time, if I perform the derivation, I will get that velocity of A plus velocity of B plus 4 times velocity of C equals to 0. And as you can see here, velocity of A is given, velocity of B is given, so I can deduce the velocity at point C. Okay, let us repeat again together while seeing the solution. So first, as you can see in this figure, the first step is to choose the coordinates. So we need 1 coordinate for the motor A, 1 coordinate for motor B, okay? And this coordinate represents what is entering inside the motor, because the motor is drawing the cable. The third coordinate needed is for the load that is lifted upward. And here, this distance is a constant, so I don't need to know what what is the value of H, because when deriving, it will be cancelled out. So again here, I will show you again the total length. So from here to here, you have SA. You have SA plus a certain constant. Then you should add SC for the first time, plus constant, plus SC for the second time, plus another constant. Now, plus SC for the third time, plus another constant, and plus SC a fourth time, plus a constant. So in total, I have SA plus SB plus 4SC equal to a constant. Now, as we said, all we have to do is to derive this expression with respect to time. So if I derive A plus SB plus 4SC with respect to time, I get VA plus VB plus 4VC equals to 0. So VC is equal to minus VA minus VB, okay, over 4. So here, by just replacing VA and VB by the values given, which are VA equal to feet per second and VB equals to 4 feet per second, when replacing into the equation, I get that 4VC is equal to minus 6. So VC is minus 6 over 4 equals to minus 1.5. And the negative sign will show you that your load is lifted upward, because here you know that SC is positive downward. This is why when you get a negative result, this means that your load is moving in the negative direction up. Okay? Any question on this? I have tried everything you told me about concerning I don't know what is the problem. My computer is not muted, and even if I put Control plus M, or even if I do anything else, nothing is changing. I cannot hear you. I will fix this after, but please, if you have questions, you can type them. So, Joe, you are asking in exercise 7B, B equal to L over M. Let me check. Yeah, problem 7. No, B is the unit, the 1 over meter. Okay, here in this problem, once I put 1 over m, this means that the unit of B is meter minus 1, because look here, you are multiplying B by x squared and y is in meter. This is why the unit of B, to have the same dimensions in your equation, the unit of B should be meter minus 1, because when you multiply by meter squared, you should get meter. Okay. Any other question on the problems, please? If you have questions, ask them. Okay, so let us continue now. If you have any questions on the previous problem, just type them here. I will respond to you. Okay, yalla. Let me see 1 second. Joe, you asked why AZ is 0. AZ is 0 because if you go back to the problem, Joe, you are asking about which problem? In problem, can you just tell me in which problem you are asking about AZ? It is this one. If you are asking about problem 8, in case you are asking about problem 8, AZ is 0 because, as you can see here, Z is given function of theta, okay, and Z dot is function of theta dot. But we figure out that theta dot is constant. Why theta dot is constant? Because they said that speed V is constant, okay, and since speed V is constant, when we derive together theta dot was calculated function of V here. So theta dot is function of V, and since V is constant, so theta dot also will be constant. And because theta dot is constant, and z dot here is h over 2 pi theta dot, then z dot is also constant. And when you derive a constant with respect to time, you get 0. So no az. Okay, so here az is 0. You are asking about this problem or about another one? Kevin, in problem 8, part A. Yes, I will repeat it. Okay. In problem 8, so this one you mean, okay? Exercise 8, part, the acceleration. Okay. How to get the acceleration in this problem? Look, whenever you have cylindrical coordinates, the first step to do is to say that A will be divided into AR, A theta, and AZ. Okay? So to calculate the magnitude of A, you should find AR, A theta, and AZ. Then you should do radical of AR square plus A theta square plus AZ square. Okay? So let us start step by step. First, we know that AR is given by what? So if I want to write the expression of AR, when you calculate AR, it is given by AR equals to R dot dot minus R theta dot square. Okay? But here in this problem, they told you that R is constant. So if you have constant R, this means what? This means that R dot dot will be in this problem 0 because R is constant. So AR will be only restricted to minus R theta dot square. Okay? And we have already calculated from the velocity, from V, we have calculated the value of theta dot. So all you have to do is to replace theta dot you got here into the expression of AR. So you get that the radial acceleration is minus R theta dot square. Okay? Now, concerning A theta by definition, okay, A theta is given by R theta dot dot, okay, plus 2R dot theta dot. So if I write the expression of A theta, it is R theta dot dot plus R theta dot square. So plus R theta dot square. Sorry, plus 2R theta, 2R dot theta dot dot plus 2 times R dot times theta dot. Okay? Because of this, here in this problem, we have demonstrated, since R constant, no R dot. Yani this term 2R dot theta dot will cancel out. And because theta dot is constant, theta dot dot will be also 0. So no value of A theta. A theta is 0. Okay? And for AZ, finally, for AZ, okay? To get AZ, you need to derive Z dot. But Z dot is a constant. Okay? Because here you got Z dot is function of theta dot, and theta dot is a constant. Because that dot is constant, when you derive a constant with respect to time, you will get that AZ is also 0. So in problem 8, your acceleration will only have a radial component. It will not have A theta, it will not have AZ, and it can be just calculated by minus R theta dot square. So the magnitude of AR, the magnitude, will be plus R theta dot square. Okay?
Yes.
Any other question on the problems we did? Let me check. Okay. So if you have any additional questions on these problems, type it. And whenever I see it, I will respond to you. Okay? So let us continue now. So now we will solve problem 11. Okay.
Doctor,
We have two motors A and B drawing in their attached cable with an acceleration of 0.2 t. So here we have motors that are drawing cables inside the motor at an acceleration variable with function of time. A is equal to 0.2 t meter per second square, where t is in seconds. Determine the speed of the block when it reaches a height of 4 meters starting from rest. Knowing that starting from rest, h is equal to 0. Also, how much time does it take to reach this height? So let us look at the figure in detail. So this is the figure of the problem. Okay, we have two motors here, two motors A and B, and we are trying to lift the box upward. Okay, the initial position of the box was here at the initial position. Okay, so this was the initial position of the box. So it will be lifted upward when the motors will draw the cable. The box will be lifted upward. Now, in this problem, they gave us delta H. Yani what is the distance of lifting of the box? This is given, okay? And we will try to use this information to determine in the problem, the question is to find what is the time needed to reach this height and what will be the speed of the block when reaching this height. So first, we should find the velocity of the block when reaching the height, h equal to 4 meters, and we should find also what is the time needed to reach this height. So to do this here, let us go back to our figure, okay? First, whenever you have a problem of pulleys and cables, okay, the first step to do is to find how many coordinates do I need. How many coordinates should I put on my figure? And then I will write the cables, the length of the cables, function of these coordinates. Okay? So to start with, if you look at your figure here, what are the moving objects? So first, you have your box that is moving. Because your box is moving, you need a coordinate for your box, okay? But since your box is related directly to the center of pulley C, then they will move together, okay? So no need to take two coordinates, one for the block, one for the center of pulley C. It's just enough to consider one coordinate for both, okay? So for example, if I consider any reference line, I can take, for example, the reference line, let's say, if I take this reference line, okay, passing by the center of this fixed pulley, this pulley is fixed to the ceiling, then a first coordinate needed will be S of C, this one, okay? So first, the first coordinate I need is S of C. So this is S of C. Okay. Now let us look now at pulley D. Is it the center of pulley D? To know if it is moving or not, I should look at what this point is attached to what. If the center of a pulley is attached to the ceiling or to a fixed level, then the center is not moving. But here, the center of pulley D is attached to the periphery of pulley C. This means that the center here is moving, okay? So since it's moving, I need a coordinate for this pulley. So the second coordinate I need is from the datum to point D, okay? And this coordinate, I will call it S of D, okay? So this is S of D. Now, What other coordinates do I need? I need also a coordinate for a motor at A and motor at B. Okay? The motor is drawing the cable inside it. So I have this. This is SA. It will represent the length that will be from here to here plus what is going inside the motor A. And I need a coordinate for point B. So this is S of B. Okay? So here in this problem, I have 4 coordinates: SA, SB, SC, and ST. And I will try to relate them. I will try to find a relation between these coordinates to be able to get relation between their velocities. Okay? So now the second step is to look at how many chords I have in my problem. Okay? So I should follow the chords and see from what point to what point each chord is going. Okay? Let me start by the first chord. Just here, because it's a little bit complex, okay, I will take for you the figure and draw it with colors on paint. Okay, so just let me share my screen again with you and take the picture and put it in detail here.
Bonjour. قد ايه نضحك اذا فجأة بيمشي عندنا الميكرو السبيك.
في أول بتمرار ما كان على أصوات
هي بركة عم تمثل.
أصلا فيها بتسمع ريكوردينج بتسمع.
يا زلمة الدكاترة بتعلم بالال وبالاي بي وبرومي وعندها 100 شغلة وعندها عائلة بقى تيجي تحضر الريكوردينج.
Okay.
لا تشوف جو ميشيل شو عم يعمل.
Please, if you see the paint file, let me know. Please type in your chat if you are seeing the file or no. Are you seeing the figure on paint? Okay.
Yes دكتور فينا نشوف.
So here first
لك شو محمد رايح
شو بيك بول؟
we have, as we said, okay, we have several coordinates. Now let us put the coordinates again together on this figure. So if I take, this is my datum, okay, I have one coordinate for motor A. So this is S of A. I have S of B. So this is S of B. I have the coordinate of for D, S of D. And I have S of C. Okay. So let us put them SA, SB, SC, and S of D. Now, in the second step, I will follow my chords. I will look how many chords do I have in this problem. Okay? To start with, the first chord is going from here to here first. This should include this length plus what is going inside the motor. Okay, so from here to here, I have SA. Then from when I continue, since I am turning over the police, this is a constant. Yani I will put it with the constant. Okay. Then from when going downward, from here to here, I have SD, because this distance is from the reference to the center of pulley D. Then I am turning over the pulley, so again it is a constant. Okay. And after this, I'm going upward again until the ceiling level. So this part I have here SD plus this small length here, which I will call H. This is a constant H. So also I can include it with the constant. So now, in summary, if I want to write the length of the first chord, so for chord, let me put a bigger font for you to see it well. So now for chord 1, okay, for chord 1, the total length is SA plus, we said we have SD here for the first time, and here SD for the second time. So SA plus 2S of D equals to a constant. Okay, so if I derive this relation, I have VA plus 2 VD equals to 0. So this is relation number 1. Okay, now I have another chord in my problem. I will put it in another color. So I will put it in blue. Okay, for the second chord, I start first from this point to this one. This part is equal to what? This length from here to here. It is the difference between SC, because look, SC is from here to here. This is SC. This part, the small part, is the difference between SC and SD. So the first length from here to here, I can say that it's equal to SC minus SD plus. Now here, of course, I have a constant part. When going over the pulley, it's a constant, so I will put it with the constant. Then when moving from this point to this one, this is S of C. Okay, so I will add plus S of C now. Then if I continue, I am turning over the pulleys, which this is a constant length. So I am turning here. Okay. Of course, كمان here, يعني this part is from this point to this one, but it is equal to SC minus a constant. So the constant also, and hell part is constant. It will be lumped with the constants. Okay. So from here to here, it's SD minus a constant. Then I have a small constant over the pulley. Now, when going from this point to the motor, yani this length, plus what is going inside the motor, is SB minus this part, which is a constant. So also I will lump it with the constant. So now I will add plus SB equals to, all constants will be considered in one term, so I will take them together, equal to constant. I will repeat. Okay, so let us do it again. I will put for you the figure again to see it. Okay, so for the first chord, I have from here to here, it is SA minus a constant, but هناخد الكونستانت مع بعض. So here I just have SA. This is a constant part. From here to here I have SD. Okay, here I have a constant, and here I have SD. So in total, for the first chord, it is SA plus 2SD equal constant. For the second chord, this part is SC minus SD. Okay, this part you have then a constant. Then this part is SC but minus a constant, so the constant will be taken lumped with the other constant. So until now I have SC minus SD, okay, plus SC another time, and finally I have this distance, which is SB minus constant, so it's SB. and all constants are taken together in one term. So now if I derive this relation with respect to time, I have 2 VC minus VD plus VB equals to 0. This is equation number 2. Okay, but it's not enough for me because I have several unknowns here. Okay, what I should do, I should use the given. In the given, they said that the acceleration of A, the motor A, is equal to the acceleration of motor B is equal to 0.2 t. This information is very important for me. Why? Because knowing that the acceleration of A is equal to the acceleration of B is equal to the velocity of B is equal to, since we are starting from rest, okay, we integrate this function, it's 0.1 t squared. Okay, so this is the velocities of A and B. Now, once we have found that VA and VB are equal and we express them as function of time, then we can say that the number of unknowns is reduced here. Okay, because now if you replace VA and VB in your equations, okay, function of time, then you will have still the unknowns that will still are VD and VB. Okay, so now when replacing VB is calculated, VD and VC. Okay, so VD and VC are still unknown, but when you replace VA and VB by their expression, you can get the functions VC and VD. Okay, so from this system of two equations with two unknowns, you can get what is VC and VD function of time. Okay, and once you have the expression of velocities at C and D function of time, now you will use the second information provided. The second information provided for you is the height, the change in height of block C. Okay, if you know the change of height of block C, then you can use it to get the time needed to lift your box. Why? Because you know that when you write a relation between velocities, okay, this relation also will be applied to delta F. Why? Because you know that V average, okay, the average velocity can be calculated as delta S over delta T. Okay, delta S over delta T. And you know that these relations you are writing here are relating instantaneous velocities. So this equation is valid at any time. Okay, because the instantaneous velocities always will verify these equations. So of course the average velocities also will verify the equation. So because instantaneous velocity at A plus 2 times instantaneous velocity at D equals to 0, then I can say also that V average V, so let me put it in bold. Okay, so you can say that VA average, okay, plus 2 VD average is equal to 0. And by replacing V average by its value, V average is delta SA. So here, so V average is delta SA over delta T. Okay. And VD average, you can replace it by 2 delta SD over delta T.
ايه اما كيفك؟
equals to
دكتور
0.
كان مثلا علي صوتك ما
And of
بتسمعك
course,
عادي.
we can simplify delta t from
علي بعد
the
صوتك.
two sides. Okay, so we can deduce that the equation of velocities apply also for equation of displacement. So if you have the equation VA plus 2VD equal to 0, you can also write that delta SA plus 2 delta SD equal to 0. And if you have that VA is equal to VB,
شو قلتوا لي
you
شو
can
عملت؟
also write that delta SA is equal to delta SB is equal to the integration of this term. The integration of this term is 0.1 t cube over 3. So 0.1 t cube over 3.
راين
Okay.
انجلش
So now you know the values of delta SA and delta SB. Okay. And you know the relation between delta SA, delta SD, and also from this relation you have another equation. So you can write also that 2 delta SC, 2 delta SC minus delta SD
راين بليز ميوت عم نسمع.
plus delta SB equals to 0.
هيدا حضرتك كمان دكتور البرسبكتيف.
Okay. So here, since you have all of these equations, then by replacing delta SA, delta SP by its function of time, okay, and applying the two equations for position, so this is equation 1, delta SA plus delta SD equal to 0, and equation 2 is 2 delta SC minus delta SD plus delta SB equal to 0.
تسمعيني؟
Then you can find, okay, by eliminating between the two, because delta SA is equal to delta SB, okay? So here you can write, you can replace delta SA from the first equation by minus 2 delta S of D, okay? And since delta SA is equal to delta SB, you can replace it here in this equation. Then you can find a relation between delta SC and delta SD. And this will allow you to solve this system, okay? So once you get delta SC function of time, and you know what is delta SC, it's 4 meters, okay? You know that delta SC is equal to 4 meters, then you can find the time t, okay? And once you find just one note, delta SC is not +4, it's -4. Why it's -4? Because SC is positive downward, okay? You have considered SC positive downward while your block is moving upward, okay? This is why delta SC is negative. So I will repeat everything because this problem is a little bit complex. I will repeat it with you now with the solution, so you will see the solution in detail. So I will go back to the file. Okay, so here, these are the different steps. Just tell me, do you see now the file again? Okay, look, I will share again. Okay, I will share again. One sec. Yeah, I will share again the screen. One sec. Do you see the screen now?
Yes, doctor.
Okay.
دكتور عم تسمعيني؟
So look, I will leave the meeting and enter again, okay? I will leave the
إذا
meeting and
تسمعيني
enter
زعفي
again.
مرة تانية.
شو قلت لك هون؟ هيك بنأمن أحسن ما تكون سمعت ولا شيء.
ليك أنا بتفوت بيكون مشي المايك عنده.
إيه.
مشي السبيكرز بس تسمعنا.
يلا.
نضحك. جوزة
ايه بس كيف بدنا نكتشف هذا الشيء؟
هذا السؤال.
انت على فكرة
هلا
جوزة
انسى
ضابط
التعيير.
بيجوا بيزقوك دغري.
مين بيزقني؟
عم قال لك
الفيجنز.
جوزة ضابط بيجوا بيزقوك دغري.
عن جد؟ حلو.
قول ما تعطى الهام اظنك مجي وما حدا بيقرب عليك.
شو انك قوسي في هناك
عن جد جلد.
الوقت.
صباج. ليكو صار التنتين مش خلص؟ التنتين بيخلص؟
210.
اوكي ما
معنا 5 more minutes.
من الوحدة وخمس
حجزين حجزين.
دقيقة.
أو تفوت ما تلاقي
قوموا
حدا.
نطلع كلنا وخلاص.
فكرة.
وصلكم ايميل داينامكس؟
ايميل شو؟
يي بعد عنا 5 minutes يلا.
كيف هذا الشباب؟
رايان هدي هي.
Guys, now do you see the screen again?
Yes.
Yes, can you hear
Yes.
me?
Here.
يا صاحبي اعطينا. الو دكتور مش سمعتينا؟
Okay. Yeah. So I will repeat, okay? I will repeat everything. Look,
Okay, deal.
in this problem, okay, you have two motors drawing the cables, and your purpose is to lift the
لا
box.
رجعت عيد
Okay.
شيء هلا.
So this is why the first step is, as we said, to
Doctor,
determine the coordinates.
Exercise
So we have
mode.
SA is the coordinate for the motor A. SC is the coordinate towards, SB is the coordinates towards motor B. And we need one coordinate for the pulley C, which is connected to the block. So this is S of C. And one coordinate for pulley D, which is S of D. Now, if I follow the cables, I can write for each cable the total length, okay? So for the first cable, as we have seen together, the length is SA, okay, plus 2 times SD. So here you have, if you follow the cable, from this point to this one, this is SA, then a constant, then SD, and SD again, okay? So from here you have, in the for the first, it's SA plus 2SD equal to L. Now, for the second chord, okay, you have the first part here, it is SC minus SD. Then you have plus SC, and finally plus SB. Okay, so this will give you the equation for the second chord. Now, or you can get between velocities.
عم تسمعوها؟
So as we can apply also for 0, and VA equals to minus 2VD. But since this equation applies at any instant, so also apply for average velocities. So you can say that VA average is equal to minus 2VD average. And the average velocity is computed as delta S over delta T. This is why if you simplify delta T, you will end up with that delta SA is also equal to minus 2 delta ST. Okay? And from derivation of second relation, you get a relation between delta SC, delta SD, and delta SB, which is 2 times delta SC minus delta SD plus delta SB equals to 0. Okay? So first you got equation 1 and equation 2 from deriving the expression of lengths of chords. Now, another information that you know is that the block will go upward a distance of 4 meters. Because it's going up a distance of 4 meters, then it is delta SC is -4. Why? Because SC, as you can see here, is counted positive downward while the block is moving up. Okay, so since you are moving in the negative direction, then delta SC will be -4. Okay, and because they said that the two motors have equal acceleration, so delta SA of motor 1 will be equal to delta SB of motor 2. Okay, so now by replacing in your equations, delta SA is equal to delta SB, so you get two equations with two unknowns, which are delta SC and delta SD. Okay, so now by solving the two equations, you get that the value of delta SD is equal to, you can get the numerical value, because you end up with, by eliminating delta SA and delta SB between the two equations, okay, you can get the unknown delta ST, okay, since delta SC is known. So you can calculate delta SD and the value of delta SA and delta SB from the system of two equations with two unknowns. Okay, now after finding delta SA and delta SB, this will allow you to calculate the time of motion, because you know that acceleration of A is given function of time. Okay, because acceleration of A is given function of time, you can get delta SA function of time, and this will allow you to get the time of motion. Now, before finding the time of motion, okay, we also should remember that we need also to get the velocity at point C at the end of motion. Okay, so we have still to find two unknowns: final velocity of the block and the time needed for motion. So we already know that from the equations we have first, we can get relation between velocities. So VA is -2VD, and 2VC minus VD plus VB equals to 0, which are similar to the equations of delta S, displacement delta S. Okay? And since A is 0.2t, by integration, you can get what is the velocity of A function of time, because acceleration of A and acceleration of B is 0.2t. So by integration, since it's starting from rest, you can get that V is 0.1t squared. And also by integration again, you can get S as a function of time, as we did. So since V is 0.1 t cube, t squared, sorry, then S will be 0.1 t cube over 3. And from our calculation, we got that SA equal to SB equal to 5.33 meters. So now, all we have to do to get the time of motion is to replace in the equation of position and then get the value of t needed to displace the block 4 meters. And as we have calculated already also the velocity of A and B function of time, so we can replace now in the expression of V function of t to get the velocity at A and B. But pay attention that the velocity we need is not VA and VB. We need the velocity block C. So now after getting the velocity at A and B,
شو صار؟
جايز انتوا عندكم كمان ولا بس؟
all we have to do is to go back to our.
لا بس عندك.
اوكي.
انا اقطع عين.
ايه انت وراين
كمان قطع.
انه تساعدوا على بعض.
راين بدي خبرك شيء.
خبرني، قول. مش قادر اتحمل، يلا حرقصتني.
بدك اقول هون ولا هونيك؟
مطرح ما بدك. انا وبول ما بنكذب على بعض، نحن بس بنقول الصراحة يعني، بس هو واحد بيجوا كلنا بنعرف.
وانا ولا مرة كذبت عنك راين. خذ هي.
Guys, do you hear me now?
Yes, we can hear you.
Look, I will re-explain this problem next time, okay? I will re-explain it for you next time because there was a lot of problems, connection, and I don't know why the screen was not appearing. I will try to see what is the cause of these problems, okay? And hopefully we can continue next time.
هيدا انا بالصورة.
واو
Do you have any questions before I close?
هنا الحلو على السكرين.
So if you have questions on what was explained,
تكتب.
please ask. And next time I will repeat the last problem we are doing.
شوفنا عم بحكي ما بتعرف شو عم بحكي.
Okay, thank you. Bye bye.
يلا نشوف شباب. باي.
باي دكتور.
صالح.
باي راين. باي بول.
باي رايان.
باي بابلو.
رايان بدك بوسه؟
هي اللاكش $1.
ايه فاصل.
يلا احكي تعال.
قومنا نلكشوا على الجروب احسن، بركي بيطلعوا مصاري. يلا باي.